Let's go to exercise number 4. We need to find the value of x in the figure LIVE. You see, LIVE has two pairs of opposite sides that are parallel. Therefore, it is a parallelogram. Now, you see, let's place here O. The diagonals, what happens to the diagonals? What's the theorem again on diagonals of a parallelogram? The diagonals of a parallelogram bisect each other. Very good. So they are equal. So we say 4x is equal to 5x minus 4. Let me do the reflexive property, okay? 5x minus 4 equals 4x. That's the transposition. Transfer. So we have 5x minus 4x is equal to transfer 4. So x is equal to 4. Questions? If the question is, what theorem supports this? The theorem that supports this is the diagonals of a parallelogram bisect each other. Next, we'll go to exercise number 5. Now, let me draw another O, okay? The point of intersection. Now, can you tell me what is the relationship between segment LO and segment OV? LO and OV, what's their relationship? Are they supplementary? Are they congruent? LO and OV, what is their relationship? Let me ask AP. AP, what's their relationship? LO and OV.
Congruent.
Very good. They are congruent. Why are they congruent? What's the reason? What theorem supports that? Where's now AP? AP, what theorem supports that they are congruent?
Wait lang. The diagonals of parallelogram dissect each other. Wait.
Very good. That's
dissect
it.
each other?
Yes, that's it. That is the theorem that supports. So we have LO. Let me now solve. LO is x plus 2y. OV is 12. So we just have x plus 2y equals 12. That's it. That's the first one. Now, how about EO and OI? What's the relationship between EO and OI? This one and the other one. Can I ask Faith? What's the relationship between EO and OI? Are they congruent or supplementary?
Congruent, no?
Congruent, very good. What theorem supports that? What AP said a while ago, the diagonals of a parallelogram bisect each other. So EO is 2x plus y and OI is 9. Here's our second equation. Let us write the two equations here. Now, you need to review your substitution and elimination in grade 8. We need to solve for our x and our y. So let's start here. We need to eliminate x. And since there's 2 here, to eliminate our x on top, we need to multiply it all by -2. So that it becomes -2 times x, -2x, -2 times 2y, -4y, -2 times 12, -24. Then we write the one in the bottom. 2x plus y equals 9. So -2x plus 2x cancel. -4 plus 1, that's -3y. -24 plus 9, that is -15. Divide all by -3, so our y is equal to 5. We now have our y. Now let's go back to this one. Let's substitute. That's x plus 2 times y, 2 times 5 equals 12. X plus 10 equals 12. The other side. So x equals 12 minus 10. Our x is equal to 2. So our answers are x equals 2 and y equals 5. Any questions? No questions? Yes, AP.
How did we get -2, ma'am?
How did we get -2? Because our x of the other side of the other equation is 2x. So we need to subtract the opposite. We only have x here, right? So to make it the opposite of 2x, we will multiply it by -2. Another example, we have x and the other is 5x. So to make this x 0, we'll multiply it by -5, the opposite. Other questions? Let's go to number 6. We need to find the values of x and y to make the quadrilateral save a parallelogram. Now, how will you make this a parallelogram? SA must be congruent to EV. So, let's have 4x plus y equals 11. There. The other one is SE must be congruent to AV to make it a parallelogram. So 3x minus 2y equals 22. Okay, now for x we have 4 and 3. For y we have -2 and 1. So let's make our y 0. Work on here. What's the sign for y in the bottom? -2y. What makes it 0? If it will be added with 2y. So how will you make y into 2y? We multiply all by, where's AP now? AP, how will you make y into 2y? We'll multiply all by 2. So let's have the first one. 2 times 4y, 8y. So, sorry, x.
Wait lang, ma'am.
Yes. 2 times y is 2y equals 2 times 11 is 22. Let's copy the next equation. 3x minus 2y equals 22. Here, 2y and minus 2y. It's now 0, right? Because they are opposites. So we are left with x. 8 plus 3 is 11. Copy the x. 22 plus 22 is 44. Divide both by 11, the numerical coefficient of x. So cancel. We're left with x equals 4. So our x now is equal to 4. We now have our first value. So let's go to our first equation. 4x plus y equals 11. Let's substitute x to the value of the equation to solve for y. So we have 4 times 4 plus y equals 11. 16 plus y equals 11. Transfer to the other side. Y equals 11 minus 16. So our y is equal to negative 5. If we substitute, this is 4 times 4 plus negative 5. That will be 16 minus 5. The answer is 11. So these two are equal. How about the other side? 3 times 4 is 12 minus 2 times negative 5. That's 12 plus 10. The answer is 22. So they are equal. It means that this is now a parallelogram. Questions? No questions? Let's go to the last one. Okay. In this one, I completed the statement. We call this a 2-column proof. It means we are proving, and the statements must be logical, and we provide the reason. Now, what is being asked? Triangle SAV is congruent to triangle VES. We need to prove that quadrilateral SAV is a parallelogram. Actually, they say this is the hardest part in geometry. But let me tell you, when I was in high school, this was my favorite part. Now, let's start first. SAV and VES. Remember, this is equal to itself. My technique is I start marking equal parts. So example, SA and VE are equal. So SA and VE are equal. Next, AV, these two, and ES. You see my pattern, the last two and the last two. AV and VES are equal. So let me mark AV and ES. There. The first and the last, SV and VS. This is the one. It's equal. For the angles also, angle S is equal to angle V, this part. Angle A is equal to angle E. So we're now marked. Now let's have the statements. Triangle SAV is congruent to triangle VES. The reason, that is our given. Next, because they are equal, so SA is congruent to VE and SE is congruent to AV. The reason, hope you can still remember Cpctc. What do you mean by Cpctc? Let me type in the chat box. Cpctc means corresponding parts of congruent triangles are congruent. It means that if they are corresponding parts like A and E, then they are also congruent. The last, you see, two pairs of the opposite sides are equal. The opposite sides are also equal. Therefore, quadrilateral SAV is a parallelogram. Who can tell me what is the reason? Why is it a parallelogram? What's the theorem? The theorem states if two pairs of opposite sides of a quadrilateral are equal, if two pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Any questions? No questions? This ends our discussion for today.